I have here a summary of all the forms of the equations for lines and planes in R3. So I'm just going to focus on these middle two here. So I want you to notice a pattern here. The lines in R3 have two equations in general form and one parameter in vector form. On the other hand, planes in R3 have one equation in general form and two parameters in vector form. So again, to say this, we have two equations here and one parameter, whereas over here we have one equation and two parameters. We can say this a little bit more generally by identifying a specific pattern here. Actually, we're going to be identifying two specific patterns. First is that the dimension of the object plus the number of equations in general form is equal to 3. So let's see, is that true? Well, here for the lines, we have two equations in general form, and we have a one-dimensional object because a line is one-dimensional, and 2 plus 1 is 3. Okay, that works there. And over here for planes, we have a two-dimensional object plus one equation in general form, which is 3. The second thing we can observe coming from the vector form is that the number of parameters in vector form is exactly equal to the dimension of the object. So here for a line, I have a one-dimensional object, and so I have one parameter. Here for a plane, I have a two-dimensional object, so I have two parameters. You can ask, okay, can I somehow make this work in R2 for a line in R2? Well, yes, I can. Instead of having this 3 here, I replace this with the dimension of the space. Then in R2, we have a for a line in R2, we have a one-dimensional object plus one equation in general form is equal to 2. These sorts of considerations are going to be paramount in the entirety of this course. This is your first example of distilling properties of subspaces to numbers.